All right, so today we are going to be talking about different kinds of nuclear energy and their uses. Okay, so the first thing we're going to talk about is fission. Now, fission is when we take one nucleus and we split it apart into two or more smaller nuclei. Okay, now in order to do this, you need to basically fire neutrons at the nuclei to make that, at the nucleus to make the nucleus unstable or more unstable usually. So when you do that, the nucleus becomes too unstable and it is forced to break apart. Okay. Now, when that happens, you have two or three neutrons that are released when the nucleus or nuclei split, which can in turn split other nucleus. So you have your one neutron, right? You shoot that at a big nucleus, okay? That nucleus then becomes unstable and splits up into two smaller nuclei. Now, when that happens, you also have neutrons that get fired away from that original nucleus. So those neutrons then go and smash into other nucleus, and the process starts all over again. You're back here with your original neutron that smashes into a nucleus and splits it apart. So it's a big chain reaction. Okay. So this has a lot of energy. So if usually when fission happens, it's in a controlled setting in a nuclear reactor, and that's how we are able to harness nuclear energy. Now, since this is such a massive amount of energy and it is a chain reaction, the nuclear engineers have to kind of slow it down sometimes. And they use these control rods in order to do that. Now, basically what the control rods do, since the whole catalyst for this reaction is these neutrons smashing into nucleus, these control rods are inserted into the uranium and they absorb those neutrons so they don't cause too much of a chain reaction. So they take away those neutrons so they can't catalyze that splitting of the initial nucleus. Okay, this is also how atomic bombs were first produced. Okay, the atomic bombs that were dropped on Japan in World War II, those were fission bombs. Okay, now the issue with fission is it produces nuclear waste, which is bad. I mean, just the sound of that is bad, right? Nuclear waste, that's not a good thing. But the thing that not a lot of people realize is this nuclear waste is bad for basically forever. Like you can't just put it into a landfill and it disintegrates kind of thing. It is pretty much going to be around for practical purposes the entirety of human civilization. Because like we said in one of our other videos, half-lives, the half-life of nuclear waste is millions of years long. So like I said, we're going to be long dead and gone by the time any of that stuff completely breaks down. So that's the problem with fission. We have to find places to put this nuclear waste. Now, we are able to do that, but there's only so much room. Plus, there have been issues where these nuclear waste storage facilities leak, and that nuclear waste runs into the ground and gets into groundwater, and then there's all kinds of issues. So while nuclear energy is really good and there's lots and lots of energy and it's better for the environment than like burning coal, there's no greenhouse gases or anything, there are still some drawbacks. All right, now the other type is fusion. Now, fusion is a fantastic source of energy, okay? Now, just like its name suggests, fusion, you are taking two nuclei and you are fusing them together, which just means putting them together, okay? Now, this requires a lot of energy because generally atoms, when they interact with each other, they just react and form other things. They don't, their nuclei don't fuse together. Okay, they bond together, but their nuclei don't fuse together normally. So that's why it requires lots and lots and lots of energy to make this happen. So, for example, down here, we have some hydrogen. Here, this is a version of hydrogen. This is an isotope of hydrogen. This is another isotope of hydrogen. Okay, they fuse together. So the green ones, those are the protons. Okay, they fuse together. and make fusion and form helium and an extra neutron. Okay, so that's nuclear fusion. This is how the sun gets its energy. The sun and all stars are made of lots and lots and lots of hydrogen. At the very center of those stars, there's so much heat and so much pressure that fuses those hydrogen atoms together to produce helium. And when that happens, that produces tons of energy. Okay, so fusion is much, much more energetic than fission. Also, it's much more clean. Okay, as we talked about over here, we have two hydrogens, they bond together, and their byproduct is helium. Okay, so helium is not radioactive, that's not a word, radioactive, and it's, clean. Okay, so that's great. The issue is, like we said, fusion requires a ton of energy to make it happen in the first place. And that's why it happens at the center of the sun. There's so much heat and so much pressure that it's not really a big deal for these things to happen at the center of the sun. But on Earth, we can't get temperatures and pressures that high, so it's really, or naturally at least, so it's really difficult to do fusion on a large scale. We have been able to do fusion on a very small scale, but not in a way that we can practically actually harness its energy, which is why we don't use nuclear fusion in nuclear reactors. Instead, we use nuclear fission, because nuclear fission we can do. We don't need ridiculously high amounts of energy to make nuclear fission happen. But we can't get high enough energy to make fusion happen, which is why we can't use it. All right, now there are several uses of nuclear power. Okay, like the first one we talked about, actually both of these we talked about already, nuclear power plants. Okay, a lot of the energy, especially in Illinois, comes from nuclear power. Okay, so what happens is they go through fission. Okay, and when they go through, or when the stuff goes through fission, it produces heat, which heats up water and produces steam. That steam then spins the turbines, just like it would in like a hydroelectric power plants, which is basically just a fancy word for saying water goes through a dam and turns turbines. Okay, but instead of using water power, it uses this heat that makes the steam that spins the turbines. Okay, so a very small amount of uranium can produce the same amount of energy as coal. Okay, so 1 gram of uranium has about as much energy in it as 50,000 pounds of coal, which is awesome, right? And especially because coal is a fossil fuel and produces greenhouse gases, which are bad. Okay, so that's why we're moving more towards nuclear power, because even though it does have nuclear waste, there's a whole lot less of it than the greenhouse gases that burning coal produces. Okay, now next thing we're going to talk about is nuclear weapons. And usually when people think of nuclear reactions and things like that, that's the first thing that they think of is nuclear weapons and atomic bombs. Okay, so atomic bombs are uncontrolled fission reactions. So like we said with the nuclear power plants and the control rods, when they put the control rods in there, they slow down that chain reaction. Now an atomic bomb, they want atomic bombs to cause as much damage as possible, right? So there's no control rods there. It's just uncontrolled. It's those neutrons are just flying all over the place without any way to stop them. Okay, so that's why nuclear bombs are so energetic. So since World War II, technology has advanced so that we've actually been able to use fusion in nuclear bombs instead of fission. Now, these are 100 times more devastating and powerful than the original fission-based atomic bombs, because, like we said earlier, fusion reactions produce lots more energy. Okay. All right, some other ways that nuclear energy is used is with, first, radioactive tracers when they inject into patients for diagnostic purposes. So, for example, a PET scan. Okay, in some of these scans, people are injected with very lightly radioactive chemicals that go through their bloodstream or their pulmonary system or whatever. And the purpose of that is so that the doctors can kind of trace, hence radioactive tracers, trace where those things go and how their different systems work. It just makes things a little bit easier for the doctors to see. There's also radiation therapy, which uses high energy X-rays to kill rapidly dividing cells, which are cancer cells, right? That's what cancer is cells that keep dividing and don't stop. So those high energy X-rays that are radioactive are able to kind of isolate those and kill them without killing too many healthy cells. Okay.